Longest common substring. Longest common substring algorithm is used to find the longest substring that is common to two strings. In case you are having two strings S1 and S2, what are you going to do? You are going to find out the longest common substring that is common to S1 and S2. Keep in mind that whatever we learned in the previous lectures, that was about longest common subsequence. What are we learning here? This is about longest common substring. There is a difference. What is the difference? In case of subsequence, the characters that are part of the subsequence, they need not be necessarily contiguously present in the original array. But what about substring? In case of substring, whichever are the characters which are present in the substring, they have to be contiguously present in the original array. This is the difference between a subsequence and a substring. Let us understand this with an example. If your string is something like this, A, B, C, D, E, F. If this is your string, then B, D, F, this is a subsequence of the string. B, D, F is a subsequence. You can see these letters are not occurring contiguously in the string, but still it is a subsequence. Is it a substring? It is not. Why is it not a substring? It is not a substring because the letters are not occurring contiguously in the original string. Instead, if you take something like BCD, BCD, this is occurring contiguously in the original string. That means BCD is a substring of the string. So BCD is a substring as well as a subsequence. But coming to BDF, it is a subsequence but not a substring. So this is the difference between a subsequence and a substring. What are we going to do here? We are going to find out the longest common substring. This is this algorithm. Let us first see what is the problem statement, and then we'll understand how are we going to solve this problem. You are having two strings. We'll call them X and Y. X and Y are the strings you are having. X is having a length M and Y is having a length N. What do you want to find? You want to find the longest substring that is appearing in both these strings. This is the task. Let us see the algorithm. This algorithm is quite similar to the longest common subsequence algorithm. There are slight modifications from that algorithm which will make it useful for longest common substring. We are going to use a dynamic programming method only, and as soon as we declared that it is dynamic programming, you would have guessed that we'll have a table. So we'll be using tabulation method. We'll be having a table. We'll keep filling entries of the table, and once you complete the whole table, you will have the final answer. This is the approach we are going to take. What are we going to have in this table? In this table, we'll be considering two strings. One string is X, which will be in one axis, and Y will be the other string, which you will keep in other axis. So each of the entry in this table, what does it correspond to? Let us write it down. So the first step is to have a DP table. You will have a two-dimensional DP table, and what is the size of this table? It should be M plus 1 cross N plus 1. This should be the size of your DP table. Why is it this size? Because the first row and first column of the table, those will be left empty. Why is it left empty? It is because those correspond to the entries in which one among the two strings are empty. For example, if X is empty string, in that case, longest common substring of X with any other string Y will be having a length of 0. Why is it? Because the length of X itself is 0, so it can't have anything in common with any other string. The same is the case in which Y is having 0 length. So in order to tackle both these scenarios, we'll be having first column and first row as zeros. Let us understand what each entry in the table is and what does it signify. If you have this table DP, which is M plus 1 cross N plus 1, what does any particular entry dp of ij signify? Let us say you have an entry dp ij in this matrix. What does this entry signify? Once you understand this, understanding this whole algorithm will be much easier. dpij, which is any single entry in this matrix, this will represent the length of the longest common suffix of x and y till this point. That is, if x is having all the letters from 0 to the I minus 1th letter, and similarly y is having all the letters from 0 till the j minus 1th letter. What did I mean by I minus 1th letter? If x is equal to, let us say, a, b, c, d, e, f. If this is x, then 0th letter is a, first letter is b, second letter is c, and so on. I am just using zero indexed because array will always be 0 indexed. So we are considering that all the letters will be present in an array or a string. So in this case, if you consider all the letters which are from index 0 to index I minus 1 from x, and all the letters from index 0 to index j minus 1 from y, in that case, whatever is the longest common suffix of these letters, that is what we'll represent by dpij. So what is the speciality of suffix? Suffix means it is having the initial part of a string. You can add anything to it. What is the use of suffix here? The requirement is that, let us say you are considering the next letter. As of now, you are considering ith letter from first string and jth letter from the second string. The whole purpose of this algorithm is, at any point, you should be able to say, if you are including these two letters in the substring, then what is the maximum possible length of the substring? At this point, you have to consider that you have only seen those letters which are till this point. In x, you have only seen till ith letter, and in y, you have only seen till jth letter. So considering only these many letters, in case ith letter and jth letter are part of the substring, then what is the largest substring possible? This is the question. So in this case, it will be the largest suffix possible, because considering all these and considering that the last letter is also part of it. That is why it is a suffix. What is suffix? If you have any particular string, let us say a, b, c, d, e is your string, that anything like a is a prefix, a, b is a prefix, a, b, c is a prefix, but f is a suffix, e, f is a suffix, d, e, f is a suffix. So whatever is from the end, that is called as a suffix, and whatever is having the first few letters, that is called as prefix. So from the word itself, it is clear. Pre means whatever is happening before. So prefix will be having those letters which are at the starting, and suffix will be having those which are having at the ending. So what did I mean when I say suffix? Considering all the letters till ith letter, that means the string, the largest string that is possible, if you consider the ith letter and a few letters previous to this which are contiguously present. This is the point. So what will it tell me at this point? At this point, it will tell me that if from string x I consider ith letter till ith letter, and from string y if I consider all letters till jth letter, if ith letter and jth letter are equal, in that case, what is the largest suffix possible? This is what I'll represent at dpij. As we move forward, it will be clear for you why exactly we took the suffix. The reason is, along with the suffix, we can add 1 if you want to consider the next letter. Let us say you want to consider I plus 1th letter and j plus 1th letter. What can you do? You can see whatever is the result produced using ith letter and jth letter. In case I plus 1th letter of x is same as the j plus 1th letter of y, in that case, whatever is your result that you produced using till ith and jth letter, to that if you add 1, that will be your longest common substring, including I plus 1th letter from X and J plus 1th letter from Y. This is the logic. So it will be clear when we complete this algorithm. As of now, just understand that dpij, any particular element in the matrix, that represents the largest suffix or the longest common suffix that is possible using X till the letters I minus 1 and Y till the letters 0 to J minus 1. What is the next step? Next is we have to initialize rows and columns. What do? You will initialize first row and first column with all zeros. This is the next step. All the values of first row and first column in your table, DP table, your first row and first column, they should be having all zeros. This is the next step. We already discussed why it is so, because if you consider the length of X as 0 or you consider length of Y as 0, in both the cases, the longest common substring will be having a length of 0. This is the reason. Next step, third step is the most important, most logical step in this algorithm. What do you do here? This is where you are iterating through each character of X and Y. You have to iterate through each character of X and Y and you want to fill this complete table. How do you fill this? In order to fill any particular entry dpij, there are two conditions. Either the letters I minus 1 and J minus 1 will be equal. In that case, what should you do? And if it is not equal, what should you do? This is the whole core of this algorithm. So in case, if it is the case that in string X, if you take X of I minus 1, that is ith letter in string X, if this is equal to Y of J minus 1, this means ith letter of X is equal to the jth letter of Y. If these two letters are equal, then what can we do? We already discussed that whatever you found using letters till I minus 1 and J minus 1, to that you can add 1 because you know these two letters match. So you have one string, you have another string, you know these two letters match. What will you do? You will take whatever is the longest common substring till the previous letter from both of those. To that you can add 1 because these two letters are matching. This is the logic. What will you do here? If it is equal, then your dp of ij, this entry can be filled as whatever is the previous one, that is dp I minus 1 j minus 1. So in case of the matrix, this will be the element diagonally above. So in case of strings, you can say considering all the letters till the previous letter. In this particular matrix, you will have it as the diagonally above element. Okay, this plus 1. This is your entry for dpij. So in case of longest common subsequence, if you remember, the logic was same. That is, in case the two strings match, the two letters of the string match, in that case, you were simply doing dpij equal to dpi minus 1 j minus 1 plus 1, because whether it be substring or subsequence, this particular logic is same. If any two strings are matching, you already have the result till the previous letters. Then what can you do? You know these two letters are matching. So whatever is the previous result, to that you can add 1. This is common logic for longest common subsequence algorithm and also for longest common substring algorithm. Next step is different. What are we going to do in the next step? Next step is, what if these are not equal? So in case X I minus 1, this is not equal to Y of J minus 1. In this case, what should you do? In case it is not equal, what did we do in case of longest common subsequence? We knew that one string is X, another string is Y. Let us say these two particular letters do not match. What did we do there? We considered the previous result of one string and of the other string. That is, for one string, you won't consider this letter, you will consider the remaining. And for the other string, you will consider this letter as well. The same you will do for this string as well, vice versa. And then you will see whichever is the maximum. This is the logic we use for longest common subsequence. But here the logic is very simple. You don't have to go to all these things because, because of the simple fact that in case of a substring, the letters have to be contiguous. Because it have to be contiguous, if these two are not equal, that means a substring is not possible by including these particular letters. It is as simple as that. You know that a substring has to be contiguous. So if these are not equal, then directly you can write dp of ij, this is equal to 0. How can you write this? Because whatever be your dp I minus 1 j minus 1, along with that you can't add anything here because the substring has to be contiguous. And you know this particular letter do not match between strings x and y, which means there is a breakage here. Once it breaks, then in case of substring, you have to again start from 0 and build a new substring here because it should be contiguous. In case of subsequence, what happened? Let us say these particular strings are not matching. At some particular point, letters are not matching. Still, what can you do? You can add the value of the next element to whatever was the subsequent present earlier. The reason is previous subsequence is also valid there because subsequence need not be contiguous. Here we are talking about substring. Substring has to be contiguous. So if there is a breakage, then you can directly write dpij equal to 0. So coming to algorithm's perspective, longest common substring algorithm is simpler than the longest common subsequence algorithm. So what do you want to do now? By this logic, you can fill the entire table. The next question is, how do you identify the final answer? I'll show you something from which you will understand that the logic should not be same as the subsequence algorithm in order to find final answer. In case of subsequence algorithm, we kept filling everything, and what did we finally do? We saw the last entry in this dp table. That was possible because in case of substring, you can add the substring even if it is broken, and whatever is the entry in the last element, that would have told you what is the length of subsequence considering all the letters of x and all the letters of y. So this would have given you the actual final answer in case of the longest common subsequence algorithm. But what about longest common substring algorithm? In this case, this particular element cannot give you the final answer. The reason is, what if the last two elements do not match? If the last two elements in the strings do not match, this entry will be 0. But you may have a substring somewhere else. Because of this, in case of longest common substring algorithm, you have to keep track of each entry you are making in the table, and in the complete table, whichever entry is having the maximum value, that is the length of your longest common substring. So the difference here from longest common subsequence algorithm is, in order to find out the final answer, you have to keep track of the values you are entering in each entry in the table. Whichever is the maximum entry in the complete table, it may be here, wherever. Whichever with the largest entry, that is the length of your longest common substring, not the entry at the last point. So keep this in mind in case of longest common substring. So what is your last step? Final step is, you have to keep track of all the entries in the table, and whichever is the maximum value in the table, that is the value of your longest common substring. Let us try to write it in a pseudocode. I'm writing the pseudocode because if you want to convert this into an algorithm, you want to write it as a code, I want you to be able to directly convert it and not get confused by looking at this algorithm. See, ideally you can simply look at this algorithm and easily convert. Still, we'll write the pseudocode because that will make it easier for you. So let us say you want to write the function longest common substring. It will look something like this: longest common substring of x and y. X and y are the two strings. What do you want to do first? First thing is, you want to find m and n, which are the lengths. So m is equal to length of x, and you have n is equal to length of y. What are the other things? Next thing is you want a DP table. So DP table, this should be M plus 1 cross N plus 1 table. And what should be the speciality of this table? This table should have all zeros. So I'm simply writing all zeros. It need not be all zeros, just the first row and the first column. If they are zeros, we are good enough. I'm simply writing all zeros here for simplicity. Then you should have two variables. One is, in order to keep track of whichever is the maximum value, you should have one particular entry called, let us say, max length. So we'll initially say max length is equal to 0. And then you should also keep track of the particular index which is giving you the max length. Why should you have the index? In order to find the substring, let us say you know what is the maximum length of the substring, but you should also know which exactly is that substring, which is that longest common substring. In order to identify that, you should know the index. So if you know the index, how will it help you? If you know the index, from that index, you can take max length number of characters previous. So whichever be the characters just before it, you have to consider max length number of characters before it. Those characters put together will give you the substring. This is the logic. So let us continue with the algorithm here. This is the index max length. In the algorithm, you have to fill the complete table. Filling the complete table means you have to go through the complete array X and complete array Y, and each entry in the table will be corresponding to some particular number of entries from X and some particular number of characters from Y. So how can you fill this? For, let us say, I is equal to 1 to M, because M is the size of X. So till the size of X you will iterate. Then you should to iterate through each of the entries in Y. So for Y, for J is equal to 1 to N. While you are iterating through each entry, what should you do? You should see whether that particular character is same in the string X and the string Y. What is the condition for that? For that you should write if X of I minus 1, if this is equal to Y of J minus 1. If this condition is satisfied, that means this particular character in X and Y are the same. If they are the same, what should you do? You should do dp of ij is equal to whatever be the longest common substring, considering all the characters previous to this plus 1. That is what you want to do. What will you do? dp of I minus 1, j minus 1 plus 1. This is what you will have. One more thing you have to be careful here is, as soon as you do the entry, you should see whether this is the maximum entry. If it is the maximum entry you had seen till this point, you should update your variable called max length. How will you do that? You will see if this particular entry dp of ij, whatever you entered right now, if this is greater than your max length, what should you do? You should change your max length to this particular value. So your max length will be updated. Max length will be updated to dp of ij. This is the updation you want to do. One more thing is, you have to keep track of the index. So while keeping track of the index, you can either keep track of index I or keep track of index j, because substring can be reconstructed from either of the strings. So what can we do now? Let us say we are keeping track of X. In that case, index will be equal to I. If you are keeping track of the other string, then index should be equal to j. Anything will work here. After this, what should you do? If they are equal, this is the case. Otherwise, if they are not equal, then what happens? If they are not equal, else, so that you understand clearly, I will write it as else if. Okay, else if x of I minus 1, if this is not equal to y of j minus 1. In this case, what should you do? You can simply put dpij equal to 0. This we already discussed. Why is it? Because substrings have to be contiguous. If these letters are not equal, That means the length of substring possible here is 0. That is common substring possible here is 0. Once you complete this algorithm, what should you finally return? Finally, you should return whatever is the max length. So here, return whatever is your max length. This will tell you the length of longest common subsequence. Let us see this algorithm once more. What are we doing here? In the longest common subsequence algorithm, we'll first find out the length of two strings x and y and store it in m and n. The next step is to define a new matrix or a two-dimensional array which is called dp. It should be of size m plus 1 cross n plus 1, and the first column and first row, they should be zeros. I just wrote all zeros. First column and first row should be zeros. You will have two variables. One is max length. This is to keep track of longest common substring length. What about the index? Index is in order to later find out what exactly is the substring. Once you find out the maximum length, in order to find what exactly is the substring, we'll use this index. We are looping through x, looping through y. For each entry, you should see whether that particular character is same in x and y. That is ith character in x and jth character in y. When you compare them, if they turn out to be the same, then your entry there for the longest common subsequence should be whatever be the entry considering all the previous characters. That is characters till I minus 1. Considering that whatever is the longest common substring, that plus 1 is the length of present longest common substring. Next step is, in case this is greater than max length, you should update the max length variable. Whenever you update the max length variable, you should also update index, because index will tell you which exactly is the longest common substring. Next step is, what if they are not equal? If they are not equal, your entry is directly 0. The length of longest common substring possible is 0 because substrings have to be contiguous. This is the logic. What is the time and space complexity here? You have to just think that in order to complete this algorithm, you have to fill each and every entry in the table. The table is of size m plus 1 cross n plus 1. So time complexity is order of m into n because mn entries are there in the table. What about the space complexity? Here the table is what is consuming the space. We already know table is of size m into n. So the space complexity is also order of mn. One more thing before you complete this lecture is that once you understand the length, how exactly are you going to find out what exactly is the longest common substring? In order to find that, from any of the strings you can find this out either from x or y. From x, let us say in case this index tracking was done for x, then you know this is the last index. For the substring, this is the last index. From that index, you should go backwards. How much backward? Max length backward. And then you should start from that point and read it towards the right. That is your substring. So your longest common substring is x of, from x, what should you do? The index, whatever be your index, that index minus max length, that should be the starting point. From here you should start and you should take all the values till the index. This is the final longest common substring. What we'll do is, in the next lecture, we'll take two strings as examples and we'll actually illustrate how exactly the whole table is getting filled and how are you going to find out the longest common substring for that. So this will make the whole understanding much clearer. This is what we are going to do in the next lecture.